Hello and bienvenidos to our first pre-calc video. Now some of you are in pre-calc, some of you are in Algebra 2. This is an option to prepare, and if you're in Okaju's class, add on to what you know from there. And if you're in Algebra 2s, you can start preparing for next year. So for this semester, we're going to go over a lot of the basic trigonometry, ratios, and trig identities and stuff like that. So you can get ready for calculus or get introduced to the idea of pre-calc. So, what is pre-calc? If you ask Wikipedia, you'll find something really complicated like this, like a branch of mathematics that studies the relationship involving lengths and angles of triangles. If you ask me, it's just pretty much triangles and their measures. So I have a few examples over here: hypotenuse, all this sine, cosine, tangent, real life examples, and a unit circle. We're probably going to get into the unit circle in about 2 to 3 weeks, depending on how fast you go in this. But for now, we're going to focus on this picture over here. So here it is, right angle triangles. We're going to focus on right angle triangles for a very specific reason you'll probably figure out later. But let me start off with this. The H stands for hypotenuse. I'm going to try to fill it in right there. The O stands for opposite. Opposite. And the A stands for adjacent. Now you might remember this from geometry. Oh, I forgot one thing. This theta right here, it's that sign, it's pronounced theta, pronounced and written like this. Now when I talk about theta, I'm going to talk about the angle. This angle right here, this angle could be 30, 60, 45, whatever you want it to be pretty much. But for now, let's review something from geometry if you remember SOHCAHTOA. Now here it is cut it for you. What SOHCAHTOA stands for is sine is opposite over hypotenuse, also shown down here. Cosine is adjacent over hypotenuse. I'm actually write that on top. Sine, cosine, and tangent, last but definitely not least, is opposite over adjacent. So let's say that this was, let's go with 2. This is 4, and this is 2 square root of 3. We're going to go into another example in a little bit. Sine of theta would be opposite over hypotenuse, shown right here, which would be 2 over 4. You can simplify that into 1/2. Very similarly, cosine theta would be adjacent over hypotenuse, so you have 2 square root of 3 over 4 or square root of 3 over 2. Tangent theta would be opposite over adjacent, so you would get 2 over 2 square root of 3. You can simplify that and get 1 over square root of 3. We'll talk about having radicals in the bottom later. Now I added on this extra layer down here. We have cosecant. Let me write it down for you. Cosecant. Secant. And cotangent. Now we're going to go into why they're called what they are in a few weeks, but for now just remember that the opposite, you can think about it the opposite. The partner of sine is cosecant, the partner of cosine is secant, and the partner of tangent is cotangent. Ooh, I don't know why I spelled that wrong. Cotangent. I don't know what I was trying to spell right there. But anyways, the cool thing about these is that it's just the opposite of the partner. So cosecant would be hypotenuse over opposite. Secant would be hypotenuse over adjacent, and cotangent would be adjacent over hypotenuse. Now to go back to the same example, let's say this was 2, 4, and 2 square root of 3. Cosecant would be hypotenuse over adjacent, hypotenuse over opposite, which is 4 over 2, or 2. Remember from before, this was 2 over 4, or 1/2. You're going to start seeing some patterns. This one over here was square root of 3 over 2. Secant would be hypotenuse over adjacent, so 4 over 2 square root of 3, or 2 over square root of 3. You're going to start to notice the patterns that this right here, cosecant, is just the inverse of that. Secant is just the inverse of that. And cotangent is actually just the inverse of that as well. So now here's where the real examples start. I'm gonna start off with the first few of them, and I want you to figure out the other ones by yourself. In the next slide, I'll give you the answers, but here is this example. Oh, and by the way, before I forget, I'm always gonna try to have SOHCAHTOA written up here because it's pretty much gonna be life for the next couple of weeks, and we're not gonna worry about specific angles yet. I'm gonna pretend like no one knows how to do this, and we're gonna focus on the ratios first. So sine of theta. Let's label our things. This is our angle right here. So this is the opposite, this is the adjacent, and this is the hypotenuse. So if I want to find sine of theta, sine is opposite over hypotenuse, or in this case, 5 over 13. Now you can use a calculator to simplify that. I'm usually going to ask for the 4 decimal points, but don't worry about that yet. Cosecant of theta is the opposite of that, so it'd be hypotenuse over opposite, which is 13 over 5. And oh my god, what a coincidence, 5 over 13 and 13 over 5. They're opposites. They're like that for a reason. Let's try cosine. Cosine of theta is adjacent over hypotenuse. Adjacent is just another word to say next. So 12 over 13. Secant of theta would be hypotenuse over adjacent, or 13 over 12. Now tangent of theta would be, let me get a different color, opposite over adjacent, so 5 over 12. And cotangent would be adjacent over opposite, or 12 over 5. So here's the actual decimal points, and this is pretty much how you're going to want to write it in the classwork online. So go ahead and ask me if you have any questions. Give this a try. Make sure you can get these by yourself and start the classwork. The classwork is a little heavy, but I know you can do it.